chm075, this is our volume 2 high alert Darwin, sorry. This is the last lab, although I guess if we change the sequence it could be your first one. But for this semester it's our last one. The lab is entitled Predicting Products and Reactants. And this ties in perfectly to what we're doing in class right now. We've been talking about a number of different types of chemical reactions, and you've been having fun balancing those, actually predicting what the products will be, plus balancing those. You've had a good worksheet on it. So today we actually get to see the chemicals in motion. So we don't get to see all the different types of reactions today, right?
No, not all of them.
So which ones do we get to see?
We're going to look at a composition reaction.
Making something?
Yeah, making something. A single replacement reaction.
Right.
Replacing something.
Right.
And a double replacement reaction. Replacing two things.
Replacing two things.
Yeah.
Oh, this sounds fun. And we also get to look at this in context of what happens when the chemical reaction takes place. Exactly. So we get to test and take a look and say, oh, there's something different there. A reaction must have taken place.
Exactly, and that's kind of the key to this lab is your observations. Make sure you're writing down detailed observations for every step. And basically observations are anything you can smell, anything you can hear, anything that you see.
Taste?
You could. I wouldn't.
Okay.
Taste.
Maybe we won't include taste.
You use four of the five senses anyway. Okay. So see, smell, see, smell. What's the other one? Hear, or feel.
Or feel.
Okay.
Yeah, those would be good.
So if you use those four, those are basically what your observations should be. Today's lab, again, what we're looking for is precipitate form. So if you get a solid formed, a temperature change.
Temperature, yeah.
Probably in most cases today will be temperature increases.
Yeah.
Okay, or a gas released, so bubbling, or something like a flocculent precipitate. That
you and that flocculent word.
Like an oily-looking precipitate in your solution. So something along those lines.
Hey, well, let's get right at it then. So now, when they're doing this lab, we're not doing it all, right?
No. What we're going to do today, we're just going to do a sample from each part of the lab. So for part A, actually for part A, we're going to do the whole thing because there is only one part to part A.
Okay.
For part B, we're going to do the magnesium portion of part B.
Oh, the fun one.
The fun one. For part C, we're going to do C part 1.
Okay.
And for part D, we're going to do D part 1.
Okay. So just a portion. When they're doing their own lab,
they'll do it all.
They'll do it all and just sort of follow step by step.
Exactly, yeah. So, and in your lab manual, it's very straightforward. It's actually it's very well written, so you can make sure it comes through in step by step.
All right. Any safety precautions today?
Definitely. Need to be wearing gloves, and need to be wearing eyewear, of course, as usual.
All right.
Very well. Okay.
Good.
Some of the stuff.
So the first one we're doing is a composition reaction.
Composition reaction, yeah. And actually, what you're going to do, before we even start, all of your chemicals you will need will be on your tables. You'll also have zinc metal that's already cut to size for you.
Right.
And magnesium metal, which is already cut to size for you. You'll also notice there's a big caution sign under the magnesium. That's because when you add magnesium to acid, it gets very warm. So be careful with it.
So don't add the acid to that beaker here.
No, don't do that.
Not a good thing?
No, definitely not. In your rack, you'll notice you have a lot of nitrates. So you have copper nitrate, lead nitrate, aluminum nitrate, barium nitrate, sodium nitrate, sodium iodide, sodium carbonate, calcium oxide. All of these are basically salts dissolved in solution.
Don't you wish they had a Scott nitrate?
They do. I'm just kidding. But if you'll notice, nitrates are poisonous. Please be careful with them. Don't drink them. Okay, they could be dangerous. You'll notice that all of your acids and bases are very high molarities. So we're talking 6 molar hydrochloric, 6 molar sulfuric, 3 molar nitric, which we're lucky that we even get to use that. Okay, 6 molar sodium hydroxide and 6 molar ammonium hydroxide. So they're very high concentrations. They will hurt you if you get them on your skin. That's why the gloves are so important.
Yep. Okay, good. Well, so let's do our composition one.
So composition, what you're going to do is you're going to add distilled water. Notice how I've labeled this test tube A. Okay, you might want to label your test tubes the same way. It doesn't matter though. You're going to go through this step by step.
Good idea to have a table sort of done beforehand, class. Do they have one in here?
They do, actually.
Oh, there is one in there?
Yeah.
All right.
So what you're going to do is fill this about 3/4 full. And to me, 3/4 full is just below the white line.
Okay.
Okay, now to that, okay,
That's just water?
That's just water. What you're going to do is you're going to put your thermometer. Oh, that was close.
Ooh, you don't want to break that.
No, it's up the. You're going to put your thermometer into the test tube. Okay?
Ooh.
And you'll notice it gets very, very close to being coming out the top. Now what you're going to want to do is you're going to want to read the temperature on this of your water. So just put your thermometer in there for a couple minutes. Chances are distilled water's been sitting out for a long time. It's going to be at room temperature, so your thermometer's not going to change. And it's actually very warm in here under the lights. It's actually 25 degrees, believe it or not.
It is warm. I'm sweating.
It's a nice summer day. Okay, now to that, you're going to keep the thermometer in the water. It says to add about 15 drops of calcium oxide. Okay, now with the amount of water I have in here, that's going to be pretty tough. So if you don't think you can fit 15 drops of calcium oxide in there, take your thermometer out and just dump a little bit down the sink.
So in terms of quantity, it's not, if
Not
we're a
crucial.
drop or two out,
Yeah,
not a big thing.
Not crucial at all.
All right.
Okay, so we're going to add this calcium oxide, and we should see something happen.
Oh, I'm excited.
Oh,
Are you
well, sorry.
excited?
Before we do that, we have to do our test.
Oh, we're doing a
apologize for
litmus test?
Litmus test. And the easiest way to do that is to take your thermometer out and dab your litmus on the end of the thermometer.
Nothing's happening, man.
No,
It's just getting wet.
and you should get something that looks something like that.
It's just wet.
Just wet. Yeah, no
It
color
didn't change color. No.
Okay, now with your thermometer in there, you're going to add calcium oxide drop by drop, 15 drops.
Oh.
Okay, so a little bit tricky.
Don't drop it. Not seeing much happening.
Okay, so we've added about 15 drops. Now the first thing I'm going to do once I've added those drops is I'm going to put the cap back on my calcium oxide. Okay, and then I'm going to measure the temperature of my solution. And in this case, as you can probably see, it's gone up by 4 degrees. It's about 28 degrees Celsius, I think. Yeah, just about 28 degrees Celsius.
So it's gone up. Temperature change.
Temperature change.
Chemical reaction.
Yeah, indicator of a chemical reaction. Now, again, we're going to test it with our
With the
litmus
pH,
paper.
well, yeah.
Okay?
It's going to go blue. It's got to go blue. No?
Well, depending on
What the acidity of it is.
what the acidity of it, it should go blue. Now, you may need to add a little bit more calcium oxide to get this type of reaction. Don't tell anybody I do this. Okay? And again, we don't get much happening to our litmus paper. So it's an acidic solution. That's okay.
Yeah. Good. Do we get to do the acid test, the litmus test on all of them?
I believe most of them. We
Okay.
get to do on most of them. So that would be the end of your part A. And you would note a definite temperature change. And if your litmus paper turns blue, That's okay, too.
There'd be a pH change
pH
too.
change as well.
Interesting though, because in the beaker it was just clear. He added the calcium oxide, and it just stayed clear. I couldn't visually see anything. However, we did see a temperature increase and perhaps a pH change. All right,
Okay.
good. Is that it for the first one?
That's it for part A. Now for part B is a little bit more exciting.
Single replacement.
Single replacement reaction. Again, we have our labeled test tube.
Yeah.
Okay, now in this labeled test tube, we're going to put 30 drops of hydrochloric acid. Now this is 6 molar hydrochloric. Be careful.
Don't taste this one.
No, this is a dangerous one. Okay, so again, 30 drops. I mean,
You haven't been counting. 19, 14, 23, 19.
30. So we're going to put 30 drops in here. Now,
How much is that, just gauging?
gauging, that looks like about 6 milliliters or so.
All right, inch high,
Yeah, about that.
inch and a bit.
Somewhere
All right.
in there.
Hydrochloric acid, not water.
Not water. Hydrochloric, 6 molar hydrochloric acid, when you mix it with magnesium, reacts violently.
So we get to use magnesium.
We get
Oh,
to use
all
a little bit of magnesium. Now,
right. It reacts
one of the-
violently.
one of the products of magnesium and hydrochloric acid is hydrogen gas, which is very flammable. be careful, okay? Be
Don't
very, very
smoke
careful.
around this
Do
experiment.
not smoke around it. And please, please, please hold the test tube away from yourself, okay?
Now, is it going to get warm too? Like,
is.
should they just leave it in one of these?
Well, what you're going to do is you're going to, first of all, you're going to measure out and record the temperature of this solution. So I'm going to take that out, okay, dry it, rinse it with distilled water and dry it,
It's dry.
okay, and we're going to stick it into our hydrochloric acid. And we'll notice that, again, the hydrochloric acid will be roughly around room temperature,
Yeah.
roughly,
Yeah, yeah.
okay? Now, in this case, okay, we're going to remove the thermometer.
Good idea.
Okay, so we're going to remove the thermometer in this case, place it in our test tube rack, okay, because you'll notice what's going to happen here. Okay, when we put the magnesium into the hydrochloric acid,
Oh, I can hear things. I see smoke.
you hear a reaction, you see a gas forming.
It's
And-
going nuts in there.
You'll also notice, if you were able to touch it, you would notice a temperature change. Okay, so you saw a gas form. We had a reaction happen, and
Oh, you're going to check the temperature again.
just to check the temperature,
Oh, it's zooming up there.
and we definitely have a temperature change, almost to roughly about, well, it's going to
Yeah,
go
it's
up to
still going
about
up.
36 degrees centigrade, which is
Yep,
quite a
36,
bit warmer
37.
than room temperature. So,
Hey, and there's no more magnesium in there.
and the magnesium has gone into solution, that's right. Okay, so make all of those observations when you go through this.
That's a good one. I like that one. My favorite so far.
Favorite so far?
The first one a little
A
dry.
little boring, yeah, that's okay. Now the other thing we're going to do, okay, next step, pardon me, excuse me, sorry. Okay, now make sure you record all those observations again. You're predicting products and reactants, so make sure you have a balanced equation for it. I mean, this one's a pretty simple balanced equation. You should be able to figure it out on your own, but if you don't know, ask.
And it seems like things are going by fairly quickly. So
Yeah.
if you think that you've messed one up, you can always. There's lots of magnesium there. You can always do it again, just in case you think you might have missed an observation. Plus, it's real fun, the magnesium.
Yeah, try the magnesium out. Again, with the magnesium though, make sure you're holding it away from your face. Okay, make sure you're holding, it gets really warm. Don't hold it by the bottom of the test tube, it will actually burn you. It's quite warm, so just be careful with it. Okay, now, this one here, we've already pre-labeled these ones again. This is C2 as an example.
All right.
Into C2 we're going to put in 30 drops of aluminum nitrate.
Aluminum nitrate.
Mm.
30 drops.
30 drops.
16, 49, 8, 10, 12, 14. You're not listening to me at all.
Oh, I put in 32.
32. That's
32
all right.
drops. Okay, so I've got approximately 30 drops in here. And again, we see it's about 6 mils, okay, give or take.
Again, it's clear.
Clear solution. Make sure, again, I can't stress this enough, make sure each time you're making observations, each time you're saying, okay, it started off as a clear solution. To that, what we're going to add, this is C number 2, and it tells you all of the steps in your lab book. To C2, we are going to add ammonium hydroxide, NH4OH.
We're going to test the temperature first?
I don't think we need to.
Oh, we don't have to. So I cleaned this for nothing.
Oh, no, we do need to test
Oh,
the
well,
temperature
give
of
us
this
this
one.
temperature.
I bet you it's going to be roughly 25 degrees.
I'll bet it is. Because it's room temperature.
And it is roughly 25 degrees.
All right. Okay.
Okay, so I'm going to give you that.
I'll take care of it.
Okay. And what we're going to do is add in ammonium hydroxide, which
Oh, I
again
don't want to watch.
is a very strong base. And what do you notice
Ooh.
happening there?
I see some sort of cloudy stuff happening in there.
What do we call that?
Well, I don't know if it's a flocculant level or if that would be a precipitate.
This is a flocculant precipitate.
Right on. I was right
Go
in both
figure, yeah.
accounts.
So this is a flocculant precipitate that's formed in here, and you can see it right in the middle as it's a white jelly-like substance.
Yeah.
And what we're going to do again, make that observation. We get a white jelly-like precipitate formed, and then we have to measure our final temperature again.
Oh, temperature again.
So we're going to measure our
Ooh.
temperature again.
I didn't clean this off. Won't matter too much,
No,
right?
not for this one. This one will be okay. Okay, and again, we will notice probably just a slight temperature change.
I
And
like the flocculant precipitate.
And again, this one's gone up just a little bit, probably about 2 or 3 degrees. So there's a slight temperature change again. Normally where there's a temperature change, there's a reaction. or in fact all the time when there's a temperature change in this reaction. So
Yeah.
again, you're going to do basically those same steps for C1, C2, C3, C4, all the way through.
Noting observations for each one of them.
each one, and temperature changes for each one. And
Okay.
that was just an example. I just chose the aluminum because it had the, I got to say flocculant again.
Now, can you, do we have to do some litmus testing on these ones too?
At this time, no, you don't. I don't believe you have to do litmus on this one.
So we're observing precipitate or a flocculant level that happens and any temperature change.
And temperature change. Yep.
Okay, good.
So we have, the last step is D. Now we'll go through this one start to finish because it's a little bit more tricky than the other ones. So into D, you're going to put in 30 drops of sodium carbonate.
So this is our double reaction.
Yeah, this
So
one,
it's a two-stepper, both double replacement reactions.
exactly. This is a two-step double replacement reaction. So again, we're going to put 30 drops. This seems to be a common theme.
You're not counting.
I am so.
Oh, are you?
30.
30.
So again, we have our sodium carbonate, 30 drops of sodium carbonate. Okay, we're going to measure again the initial temperature of this one more time. So we have a clean, dry thermometer.
I didn't really clean it that well. Just a second. Perfectly clean.
Perfect. Time-lapse photography, obviously. Okay, and again, we're going to notice this is probably right on
25.
25 degrees or thereabouts.
Okay.
Okay. Remove the thermometer,
Clean it.
clean it. Okay. We're going to add to this 15 drops of barium nitrate. Now, judging by what you've seen so far, you should probably be able to figure out the barium nitrate, when you add it in here, is going to do something. Okay? And
Oh, I want to see. Oh, I'm seeing precipitate happening.
we
It's
get,
going all white.
we get a white precipitate form. Now, to that, we also have to, thank you, Jeff, for cleaning that thermometer,
Pleasure.
we have to record a temperature change. And generally speaking, with this one, we don't see much of a temperature change, if any at all. Okay, this one
Oh, interesting.
doesn't
I
have too
certainly
much of a temperature.
saw precipitate happening, though.
Oh, definitely. Definitely some precipitate, not too much of a temperature change. Okay,
Sorry, I should have been turning.
that's all right. I just don't want to screw up for the camera.
We
Okay,
never screw up for the camera.
now to this, after we've added the barium nitrate, using the same tube, you don't change tubes, you're going to add nitric acid. Nitric acid is one of the nastiest substances in the world. Okay, it's not very user-friendly. Please be very careful with it. HNO3, you'll notice that they're brand new bottles. This is because each semester they eat through the bottles each time. So just be careful with it. Okay? And to it, we're going to add 15 drops of nitric acid. Ooh, that one just comes out like a squirt.
It did. Hey, now
And-
hold on here. Hold on here. All my pretty white stuff's going away.
Yeah, you'll notice that all of your precipitate will move back into solution with a couple
Oh,
of
well,
quick
that's a
stirs.
drag.
Well, we
It
can
was
get
looking
back.
so pretty. It was like, looking sort of like Christmas.
Okay, and the other thing we're going to do is we're going to take the temperature change again. We're going to try and find the final temperature change. And again, for this one here, it might change a little bit. In fact, it is going up probably 2 or 3 degrees because you're adding a strong acid to a weak base. So you're going to get a little bit of temperature change. But for the most part, you will also notice there's a little bit of fizzing, some bubbles forming.
Oh,
Okay.
yeah.
And you'll notice that, of course, your solution has gone back to being clear.
It
Thank you,
seems
Jeff.
like I'm cleaning this thermometer all the time.
I know. You might want to ask your lab partner if they can do that for you. Okay, now, you are going to, from there, you're going to record any changes that you note to happen. Now, this is not part of your lab, but do you think if I added barium nitrate again back in, that I could get the same reaction?
Probably enough, sure.
I would think so.
Yeah. Are we doing
So-
that? Is that
Well,
the end
no,
of our lab?
This is the end of the lab, but I just
Okay.
wanted to
End it with
show.
a sort of
End it with-
Christmassy kind of.
Yeah, it's a little Christmas. Oh, look
White
at that.
precipitate.
It's going to disappoint me. I added too much acid the first time.
Added too much acid.
Yeah. Oh, well. Anyhow,
Well, that's too bad.
but that's the long and short of your lab. Now, there are individual steps in between, but you'll be able to figure those out on your own going through your lab reports.
Okay, so today, excellent example of the things we've been talking about in class, about the composition reaction and a single and a double replacement reaction. Scott wouldn't let us do the combustion reaction, but you see that one every day in your car engine and in your own body, right?
Mm-hmm.
We have some combustion in there. Lots of observations in this lab. Do things slowly, methodically. Make sure you're comfortable. You know your tables. Make sure you're making lots and lots of observations. Any final parting shots?
No.
You know, we didn't talk at all about how much any of this stuff costs today.
Well, the test tubes themselves
Yes?
are about $1,000, so
all right.
just be careful with them.
Okay. All right. Thanks.